Good morning and welcome to the very first panel discussion at the 2021 Humans to Mars Summit. I'm Matt Kaplan of the Planetary Society, where I've hosted and produced Planetary Radio for nearly 19 years. Our boss, Society CEO Bill Nye, and my other colleagues send their regards and their gratitude to our friends at Explore Mars as this year's summit begins. And we are thrilled to once again be part of it. So you've no doubt seen the title of this opening panel discussion. After years of doubt, I'm now convinced we humans need to learn how to sustainably reach and live on the moon before we can realize our dreams of walking on Mars. Is there any remaining doubt that this grand work will need to be accomplished as a collaboration among nations? That is our theme for this session, and we are honored to have three ideal, really the perfect guest panelists to address this topic and to lead us off. And we are going to start, let me introduce them first of all, beginning with David Parker, who is the European Space Agency's Director of Human and Robotic Exploration. That's a position that he has held since 2016. Prior to that, a lot of you know that he served as Chief Executive of the UK Space Agency. Then we are joined by Hiroshi Sasaki, the Japanese Space Agency Vice President and Director General for the Human Spaceflight Technology Directorate. He also leads JAXA's Space Exploration Center and Space Exploration Innovation Hub Center. And last but far from least is Kathryn Lueders, Associate NASA Administrator for the Human Exploration and Operations Mission Directorate. She's been in that job at NASA for just over a year, and prior to that, managed the very successful Commercial Crew Program. So welcome to all of you. It truly is an honor to be here with the three of you. I'm going to remind those of you watching that because of the obvious international nature of this discussion, we did have to pre-record it, which means, of course, that we won't be able to take your live questions once we have heard the presentations from each of our panelists. But we will do our best to ask the questions that you might have if you'd been able to do that live. And that will come after we hear those presentations. And we're going to go to the first of those now. David Parker, why don't you get us started?
Great. Well, thank you very much. And thank you very much for the chance to speak to you and be part of this really nice event and to be part of the conversation. I want to do three things in my few introductory remarks: explain a little about ESA's exploration program, describe the role of Mars in this vision, including our current projects, and finally, I think, to emphasize the people who underpin the activities now underway. I'm going to try and do all that in 8 minutes or so I better get going. So next slide, please. Europe's space exploration program, now named Terra Novi, meaning New Worlds, is based on expanding the human presence from low Earth orbit to the moon and onto Mars, working with international partners and industry across Europe. We have 22 member states, but just to recall, within the European Space Agency. Now, through the International Space Station, low Earth orbit has proved its value as a place for humans to live and work. I always say live and work. So right now, European astronaut with a French passport, Thomas Pesquet, is hard at work on the station and about to take command of the ISS indeed. But aboard the ISS, dozens of astronauts have performed hundreds of experiments on behalf of thousands of European scientists. So the next step is the moon. I really believe that the moon has immense scientific and practical potential. I like to call it a museum of 4.5 billion years of solar system history. And it is, for me, the next place where humans will live and work. But in our program, the red planet Mars is the horizon goal. What I mean by horizon goal, it's somewhere I can see already. It's not necessarily the end point. I can see as far as the horizon, but I know there are places beyond that. But Mars has its attraction for scientific reasons, for technological reasons, for many human reasons. Next slide, please. And therefore, our exploration program is organized around 4 cornerstone exploration campaigns, supported by the underpinning technology and scientific actions. So humans in low Earth orbit, humans beyond low Earth orbit, our support and participation with NASA in the Artemis program, robotic exploration of the moon, but also Mars. So next slide, I'm going to say a little bit about the lunar exploration activities. I'm not going to go into all of the jigsaw pieces, but I want to emphasize again the international dimension. As I say, it's great to be part with JAXA and with CSA of the partnership with NASA on Artemis. And so now we're actually we've committed already to building 6 European service modules, the power and propulsion for Orion. And ESM-1 is at the Cape right now. My teams are there preparing for the launch of Artemis 1, the uncrewed demonstration mission. And in October, we will deliver the 2nd European service module, the one that will actually propel astronauts into deep space for the first time since the days of Apollo. And then as far as the Lunar Gateway is concerned, our kind of permanent research outpost, 1,000 times further out in space than the space station, while Europe is contributing 2 of the modules, habitation module, but also refueling capability, telecommunications capability, and what is going to be one of the most exciting elements, which are the windows to look out onto the new 8th continent of the moon. So the first elements are already being manufactured across Europe. But the next slide is to just recall a little bit on why we are exploring the moon and to emphasize the feed forward to Mars. This 8th continent of the Earth, 4.5 billion years of solar system history, has been recorded more completely and more clearly than probably any other planetary body. So there's an intrinsic scientific interest. And it's my personal view that as today we have Antarctic research bases, and I'll come back to the Antarctic in a moment, I'm convinced that in the future we will have an international research base on the moon, monitoring and understanding our own star, the sun, looking back perhaps to the dawn of the universe with radio telescopes, and learning how to use the moon's resources to make exploration more sustainable, more effective. And that's the point. Many of the technologies and capabilities we developed at the moon, we will need to feed forward to Mars exploration. So next slide gives you a few examples. I don't propose to go into all of these in detail, but a few of the science and technology topics we're working on, and a particularly interesting one is in the top left here, is related to space resources. To practically extract oxygen from the lunar regolith or in the future from the soil of Mars, we need very energy efficient processes. So we're developing the power technology, but we've also recently demonstrated a promising process based on a patented European technology for developed in the mining industry, actually, as shown on the top left here. It's lunar regolith simulant. We've extracted the oxygen to leave effectively pure metal behind. So next slide, this is the Humans to Mars Summit. So let me say something about our actual Mars program. As I was reflecting, Mars Express has been in orbit now nearly 18 years. Within the exploration program today, the main elements are shown on this slide, the 2 launches of ExoMars and the 3 planned launches of Mars Sample Return. So let me say a little bit about each one of those briefly. So next slide, please. The Trace Gas Orbiter, the huge spacecraft, the largest spacecraft in orbit around Mars, has been there for more than 5 years. It's given a lot of great service. It's one of the key data relays supporting all of the NASA surface assets, whilst simultaneously carrying out front-page science investigations, understanding the atmosphere of Mars, and also probing its subsurface for water. So a fantastic workhorse at the red planet. The next slide is, of course, we've been long awaiting the Rosalind Franklin Rover mission, which is now wrapping up its assembly and test activities. Here's a bit of footage from a couple of weeks ago of the engineering test model at the Mars sandpit at the control room center in Italy. And since drilling at Mars is a really interesting topic, last week it drilled a 6-foot deep hole and extracted a sample for processing in the analytical laboratory aboard. And I emphasize the point that ExoMars is the only mission that's currently planned capable of analyzing at molecular level possible biological samples on Mars. Next slide, please. So meanwhile, we're starting the development of the European contributions to Mars Sample Return, the first round trip to the red planet. and a really exciting, probably the most ambitious robotic mission ever attempted. I can give an impression of just how complicated it is by just talking about one element. That's on the next slide, please, which is the Earth Return Orbiter. So the Earth Return Orbiter will be the first spacecraft to make the round trip to the Red Planet. I like to call it the first interplanetary cargo ship, bringing precious scientific samples back from the surface of Mars. And of course, the first one was drilled very recently by Perseverance. It's a monster spacecraft. It's 40 kilowatts of solar arrays, nearly 7 metric tons at launch, solar electric propulsion, chemical propulsion. It's a ton larger than Cassini-Huygens, or twice as big as our Bepi-Colombo mission that's on its way to Mercury right now. It's the kind of technologies we're demonstrating with Mars sample return for science that is also preparing one step towards human Mars exploration. So next slide, I'm coming towards the end of the technological part of my presentation, and maybe just press the buttons, please, so that all the elements appear. We've been looking at the future of low Earth orbit, the future of the Moon, and the future of Mars, and looking where Europe could contribute in the future. And again, you see the similarities, the commonalities and areas of interest that link the three destinations, and how we might combine, for example, our expertise in pressurized systems, pressurized modules for the Gateway with the electric propulsion and deep space capabilities of Mars sample return to prepare perhaps a human transit vehicle to take astronauts to Mars one day. But this is the Humans to Mars Summit. So in my next slide, I want to emphasize a little bit about the human element. The future of Mars exploration, in my view, lies in not just in the hardware, but in the software of the explorers. And these are two of our explorers. They're two of our ESA researchers, Beth Lomax, Alexandra Maurice. And they were the people that carried out that demonstration of oxygen extraction from simulated lunar regolith. They're the people that are building the future or path of exploration. Next slide, I mentioned Antarctic exploration. Well, ESA is deeply involved and has been for more than a decade now in Antarctic exploration. The Antarctic Concordia Research Station is really a fantastic analog of planetary exploration. The 6-month-long Arctic winter, including 4 months of darkness, hyperbaric environment, the impossibility of being physically reached by anyone except in an absolute emergency. It's a pretty good analog of Mars. And so the research we're doing there is supporting not only the technological, but the human aspects of Mars exploration. And coming towards the end, the next slide is to emphasize about the astronauts themselves. We've had a fantastic, successful campaign to start recruitment for our next generation of astronauts. But I want to emphasize the thing I put in yellow here. All the objective evidence shows that the diverse teams perform more effectively than a monoculture. It's one reason amongst many why, as part of this recent call for astronauts, we've launched the Para-Astronaut project to fly the first fully qualified astronaut who happens to have a physical disability. I think the past recent weeks of the Paralympics have brought us many fresh stories of achievements by people who are in many ways better equipped to overcome the challenges of an unforgiving environment, since life on Earth is already very challenging for them. As one of our astronauts, Samantha Cristoforetti, said, in space, everyone is disabled. And so I offer one very practical example of learning about the adaptations needed to support disabled crews. On the very long and challenging mission to Mars and back, we could easily find ourselves faced with a situation of an astronaut becoming incapacitated and perhaps even, worst case, permanently disabled during the mission. So we need to learn and to prepare, and I'm convinced that this project will contribute towards our learning and our preparation. So in conclusion, my last slide, I hope I've given you a few impressions of what ESA is doing to prepare for human Mars exploration and the Horizon goal of our Terra Novae program. Thank you. Have a great summit conference. And if you have been, thank you for listening to me.
Thank you, David. What an exciting future and present you've laid out. I have to say, it was so exciting just to see that those thousands of interested candidates respond to that call for the next ESA astronaut class. I was reading about Terra Nove, that program just last night, also very exciting. And as a planetary science guy, I cannot wait for Rosalind Franklin to dig down deep below the surface of Mars and help reveal what may be hiding down there. That's best of success to you with that very exciting mission. Hiroshi-san, if you are ready, we will go to your presentation now. Thank you.
Okay, thank you for the introduction. I'm Hiroshi Sasaki again, Vice President of JAXA, in charge of human spaceflight and exploration. I'm glad to discuss about the humans to Mars with international colleagues. Next page, please. To proceed the space exploration, especially Mars explorations, I'd like to emphasize 2 points: international collaborations and combinations of expertise. In order to achieve the result or effectively and contribute widely to humankind, it is important to cooperate internationally and to share the strengths of each country while keeping in mind the strategies of each country. In Japan as well, while there are expectations from the industries and science communities, we still thinking the importance of the contribute to the humankind. This was also discussed at the ISSRU, Second International Space Exploration Forum, held in Tokyo in March 2018, and the Tokyo Declaration was announced. Next, please. Since the beginning of humanity's challenge to space in the 1960s, we have expanded our activities. Currently, astronauts are always on the ISS, and the knowledge and technology gained from the operations and experiments are valuable to humankind. These findings have been obtained through the long-term international collaboration. At the initial stage, each country was working on its own, but international cooperation is gradually being carried out, and recently, many countries are participating, such as the ISS. Next page, please. There are various types of international collaborations. I picked out 4 types shown here. For a large system, many countries need to participate and cooperate, such as ISS. And in the medium-sized system, 2 countries can work as equal partners. We have JAXA has several missions related to the Earth observations and Mercury missions and lunar missions with US, ESA, and India. And also work to one will lead and other partners will partially cooperate, such as Hayabusa and MMX. And in a small mission, data sharing may be efficient. So it is necessary to select the suitable collaboration types, taking account of each mission. Mars exploration might be required more cooperation than LEO or Lunar mission, since it is a large mission. Next, please. This page shows Japan's technology developed before or developing. Through the ISS program, JAXA developed and operate the Kibo module, and the life support system will be used to the gateway. And JAXA also developed and operated the HTB resupply vehicle and is developing HTBX. And we also want to support the logistics to the gateway using the HTBX. As for sample return, we completed successfully twice, and we plan to develop the MMX to return the samples from the Martian moon Phobos. We are also developing the pinpoint landing mission stream and unmanned rover. We can contribute to the future international exploration with these technologies. Next, please. This page shows the current lunar exploration roadmap. JAXA launched the Kaguya remote sensing mission before, and JAXA is now developing the SLIM Smart Pinpoint Lander and Lunar Polar Exploration. And now JAXA is participating in the International Gateway and also planning the human rover. We are also coordinating among ISSRU future facility on the moon. Japan will contribute them with our technologies. Among international cooperation, some missions are led by Japan, while others are led by other countries and Japan cooperate. It is important to achieve the great results efficiently by bringing together the strengths of each partner and sharing data. Next, please. This page shows Japan's plan for the exploration of Mars, which is under study. In Mars explorations, we will collaborate internationally and aim for the effective results that make use of each other's strengths. Currently, JAXA is developing the MMX, Martian Moon Exploration, and studying the MIM, Mars Ice Mapper. Both missions cooperate with many countries, and I think that the future plan will be also promoted through the international collaboration. Through this international Mars exploration program, we can produce a fruitful result effectively, and it will lead to the manned Mars explorations. Next, please. Exploration of Mars is beyond accumulated and current international collaboration. To proceed the exploration, I'd like to keep in close contact with each country so that Japan can contribute to the exploration of Mars. I'm looking forward to taking on the challenge of the international Mars exploration together. Thank you very much.
And thank you very much, Sasaki. Again, very exciting stuff to report, both going on right now out of JAXA and your partners, and for the future. I want to, on behalf of all of us, congratulate you and your colleagues on the tremendous success of Hayabusa 2. And I will personally say how much I'm looking forward to the MMX mission and the possibility that it just might, as it brings back pieces of Phobos, bring back bits of Mars itself that might have been knocked off of the surface and sent up to that moon not far above the surface. Very exciting stuff. Kathy, we leave it to you to bring us our third and final presentation.
Yeah, I think what's so amazing to me, and just following along David's and Hiroshi's presentations, is how much we are doing this as one. You know, everybody always asks me, how is this exploration process different now than it was in the 60s? And it's mission, our science mission directorates and our human mission directorates, and we are collaborating together to maximize the benefit to all of us. Next slide. So just as Hiroshi and David talked about, we within NASA are also learning from our science missions, but within the Human Exploration Division, we're also maximizing the use of each of the platforms that we're developing, and hoping that our science mission directorates and our technology mission directorates are able to use these platforms to their fullest. And so obviously the International Space Station is a major collaboration for us, and we are continuing to use it, pushing and hoping to use it all the way through 2030, working towards extending that right now. And we'll be using it to further define and test out our systems that we need for us to accomplish our lunar missions, and make sure that our systems that we have developed and are expanding on for our Mars missions are also being used. We're also laying in an ability to be able to have a LEO platform post ISS extension to be able to continue. We know that, for example, our ecosystems currently are being tested on the ISS. We have the ability to reclaim 93% of our water on the ISS right now. We're moving towards having that be 98% for as we're moving, and even gain even better efficiencies as we're moving towards a Mars mission. That means we're going to have to continue to evolve that ECLETS technology and be able to so that we can accomplish those hard missions that we'll be gearing towards. That will help us be able to test out across our multiple platforms to be able to get to the moon quickly and sustainably, and then deliver even more missions, more science, more technology, and more innovation at a better value for the American taxpayer. You know, all this is about making new discoveries and expanding our human knowledge and pushing our human presence deeper into the solar system. And through that process, being able to return benefit to the Earth. Next slide. So we talked about the different platforms. We actually, you know, obviously have our low Earth platform. That is ISS right now, and continue to expand it. We're moving and have in process our lunar platform, cislunar platform, which is the gateway system. And we're looking at the things that we need to be testing out on our low Earth platform that also need to be checked out on our gateway platforms. What's really important is that we've used kind of the systems and the processes and the agreements and our international processes in place to be able to learn about how to operate in the low Earth platforms, and then are applying that to how we're going to be operating together on our cislunar gateway platforms. This is very important because we're also laying the foundation for how we're going to be working together with the Artemis Accords on the lunar surface. People don't, this isn't the snazzy part of things, but it's very, very important for us to learn how to live and work and share data together to get ourselves ready to be able to operate responsibly on each of these platforms on the lunar surface, and then be able to operate together on Mars. This is a very, very important part of us working together and doing research and science together as an international team. Next slide. We're laying the foundation right now for the key systems that we're hoping we all will be able to use together for us to do our deep space exploration. So right now our crew transportation system is in play, and we're getting ready to do the uncrewed demonstration of our Artemis 1 crew transportation system. We are working with ESA and JAXA and our CSA counterparts on getting our cislunar gateway systems through development, and then beginning to work the launch sequences for those systems. And we're in the process of doing our initial human landing system demonstration and putting in the contracts that will deliver our human landing systems going forward. But there is so much more that we need to do from a science and technology and continued lunar system collaboration to get us ready to be able to have the capabilities on the lunar, on our lunar surface, to be able to test out the systems that we need, and to be able to have tested out to be able to go to Mars. In addition, our lunar surface will be able to, these, you know, we obviously need to be able to figure out how to do in situ resource utilization. That's going to be a key feature for us to be able to have in place to be able to conduct our Mars missions as efficiently as possible. We're going to have to figure out, just like we had to learn with Mars Perseverance, we had to figure out how to get samples in an efficient way. Those will be the kinds of things that we'll be learning as we're doing lunar surface activities with humans and through robotic endeavors to help us more efficiently conduct the science and research. So in addition to the things that we've all talked about, you know, just doing our aggregation and the way we do our aggregation, and the planning for our aggregation, the orbits that we picked around the moon are the orbits that will more efficiently get us ready to go to Mars and have the capabilities for us to be able to buy down risk in key areas to get the team being able to conduct operations, do aggregations, work in an integrated manner that will be critical for us to be able to accomplish our Mars missions. Figuring out how easy it is logistics supplies and work through that with a lunar analog, and there'll be tremendous learning for that for us to then get ready to the complexity of what those human Mars missions will be. Crew health and safety. We've got to figure out how to make sure, and David talked about this when he was talking about having crew members and learning, and everybody does have a disability. It's actually the great equalizer of being in space. We're going to have to figure out how to keep our crews healthy, and in a place that where the first answer may not be go back to Earth. Right now, we have the luxury of when we're in Leo, all of our contingency planning, everything else says if there's a really bad problem, we just jump in the spacecraft and go home. We're going to have to be learning the capabilities that we need to be able to keep our crews safe and have mitigations in place. That's going to be in a really tough and a long mission. David talked about this. This is also the kind of learning, though, that helps us here on Earth. You know, there are tough places where people live and don't have easy access to medicine or food or some of these other critical things that we're going to have to figure out how to deal with as we're doing our lunar missions and going to Mars. And so to me, this is another area where as we're solving that hard problem and that we need to be able to do our exploration missions that we have, we're continuing to buy down specific risk areas that we also have here on Earth. On the surface, we haven't really done these kinds of surface activities on another surface except for Earth. Obviously, we do lots of analog missions here on Earth to check our systems out, which is a key test laboratory for us here. But we have to be able to go on a lunar surface, be able to test out integrated crew operations, and be able to have our EMUs, our EVA suit capabilities, be able to deal with the issues that you have with dust mitigation as you're going in and out of different capsules and capabilities. These are all really tough things to do. They'll be tough for us to do on the surface of the moon, but it'll be important for us to be able to do that and be able to check out those systems and continue to use the people and our robotic capabilities there to be able to further learn about the moon, but also get us ready to be able to do this, what will be a tremendously tough mission to send people to Mars. I love the imagery that David had about, we have this great museum capability here. It's like this access to the moon, and we'll be able to use the moon and be able to learn about the moon even more with us also conducting these missions and getting us ready as to be able to then do the next jumping off point for us to go to Mars. Next slide. How little we look when you're on Mars, and just like when we're on the Earth and we look at Mars, what that looks like. And so it's just a little taste of how far people are going to be from home when we're going to Mars, and the difficulty we'll have to be able to get there. And it's going to take some learning. It's going to take some tremendous learning. But I firmly believe that we will do that learning together, and it will be learning that will help all of us as we're moving towards our bigger goals as a planet. Thank you.
Thank you, Kathy. Thank you, Kathy. I love seeing that little pale blue dot as humans will someday see it from the red planet. I want to stick with you for a moment because you talked about what the ISS, the International Space Station, has done for us in terms of international collaboration, learning how to collaborate internationally. I like to think of it as perhaps the greatest international peacetime collaboration among nations ever. And maybe the technological achievements of the ISS over the last 20 years are more obvious. But could you say a little bit more about how it has taught all of the agencies involved to work together to make all these different systems and components and approaches mesh?
Yeah, people don't realize sometimes we make it look so easy, but there's a it took us a little while to figure out how to work together and be able to team together, and at what level we need to work together and at what level we can operate separately, right? You don't have to do everything together. And so, but it's important to have these, governance discussions and teaming discussions and ways that we work together and make decisions on a day-to-day basis and create the structures to be able to do that. Very, very important. And the ISS has been a great platform because we've evolved over time and the partnership has evolved over time. And how we work through those new evolutions together has been a growth experience for us. When we started the partnership 20 years ago, we didn't know then we were going to be doing commercial cargo and commercial crew vehicles to the ISS. And so that was an evolution that the team had to work through together. And there's been many evolutions like that along the way where we've had to work together and expand how each of the countries and each of the key agencies are using the International Space Station. And we've got to do that as a team. And that means that there's give and take along the way. But learning how to do that and being able to understand that we're doing it together and for the research and technology needs that we all have has really, I think, really been an important stepping stone for us in establishing the same processes and learning from the processes and getting ready for Gateway.
David, Hiroshi, anything to add to that?
Well, maybe I just confirm everything that Kathy says and say that there's a relationship at an organizational level, but there are a lot of real important human relationships, connections behind the scenes, and those are often more important because it's when something goes wrong, when there's a challenge. A trivial example, there's a storm in the United States, so NASA can't send its plane to go and collect an astronaut landing in Kazakhstan. Can ESA help out? Yes, of course we can. You don't start writing a contract or something to discuss that first. It's how can we help each other? And of course, NASA's tremendous experience and heritage in human spaceflight is something that agencies like ESA and I guess JAXA and Canadian Space Agency have been able to benefit from that heritage and move more quickly, maybe learn from experience and not make mistakes. But I just really want to emphasize the human connections that are coming into the space station world. In particular, I came from the outside of the space station world. I have seen how real those people-to-people connections are that make it work day in, day out, behind the scenes. Never makes headlines, but it's really happening.
Yeah.
Yeah. Also, I also think that the early phase of the ISS, JAXA is learning the similar things from the NASA. And but currently, so through the 10 years or 20 years, we learned a lot of things, and especially that how to coordinate the international collaborations, or how to design the system and how to operate the human space system. And so we can easily talk with each other, with ESA and NASA, and to develop a system or operate the system.
Thank you. Kathy, I'm going to come back to you. As it looks increasingly unlikely that the first woman and the next man are going to be walking on the moon by 2024, what is the outlook for that human return to the moon? And it does look like we're seeing substantial progress, even if it may not be moving as quickly as some people might like.
Yeah, I think we always give ourselves big goals, right? Because I think the important thing is to show that this is something we want to do in the near term, right? It's not a long-term goal. I think, obviously we have some challenges right now because we're working through some contract award pieces, so that makes that start be pushed back until we get through our contract protest pieces and everything. But I do think when we do that, the team's going to lay down, sit down with their providers and start laying out how quickly can we get there. But as we've learned, when you're trying to do these really, really hard things, and it's the first time we've had a landing in a while, it'll probably take a little bit longer than we have in our initial goals that we have, right? And so I do think it was an important thing for us to have an immediate goal. But once we get through the contract award pieces, we'll figure out kind of what we think the schedule is then, and then start laying in our planning for that. We are working with David on flying the two assembly modules for the gateway at the same time. So we do have kind of a group of missions that we're looking to accomplish in that, 25, 26, 27 time period that will be the first landing on the moon, but will then also be our assembly missions for the gateway. So I think there'll be enough excitement in those mid-20s to keep people going, even if we don't absolutely get boots on the moon in 2024. But we're still working on it.
Let me follow up on that, specifically about the gateway. Could any of you imagine taking on a project like the Gateway if we had not learned what we have with the International Space Station? David, you want to try that first?
Well, of course, the short answer is no. I mean, the very challenge of assembling all these pieces of the ISS miraculously above our heads in orbit is a totally extraordinary human feat. Now we're going to assemble, a much smaller system, but a much more integrated system, 1,000 times further out in space, and use it for 10 or 15 years or more, I'm sure, is based on the trust and the heritage and the technical knowledge that we built up on the space station. And it's also been established through the different partners discussing and saying, well, we think we could do this part, could you do that part? Now that we start to develop it, doesn't it make sense if we all use these common elements? Maybe if it's made in the United States, or Japan provides the life support systems. This makes sense. Great. When we're doing the science, we're preparing the science for the Gateway now. It's a common program of science where we decide a common vision of the science, and maybe one agency leads on one piece of scientific hardware and somebody else leads another one. But the planning and the science is done by international teams. So I think it's incredibly exciting. I keep talking about the Gateway being humanity's most distant research outpost. I come back to that vision of the Antarctic Research Station. Yeah. It's like an Antarctic Research Station, just a long, long way away.
I also love your reference to the eighth continent. I think that's going to be a lovely way. I hope that future school children will think of the moon that way. Hiroshi, Sasaki, could you also talk about JAXA's contributions to the Gateway, but also the thinking that JAXA is doing about participating in humans on the moon and in preparation for Mars? We all know that we are looking at Artemis as a stepping stone to Mars, but the moon has its own value, as we have heard throughout these presentations.
For the JAXA and Japanese government also, moon is a very important. First of all, we would like to we launched the Kaguya I presented, and it searched the water ice on the moon. And first of all, we'd like to search the water ice on the moon surface, and if possible, we'd like to use this water ice to the propellant to the Mars missions. And also, moon is a very science team is also very interested in moon surface. So, for example, some people are thinking that space observatory system on the moon, or they want to pick up the moon quake system to evaluate the moon structures. So such kind of moon science also interested from the Japanese people. And also the industries or private companies want to develop some sometimes hotels and entertainment place. They want to send people to the moon. So such kind of lots of purpose are existing on the moon. So we have not fixed them, but we want to proceed to the moon explorations for similar purposes.
I'm glad you brought up that ice, that enticing ice that we now know exists, at least at the poles and perhaps elsewhere on the moon, because it, of course, brings up ISSRU, in situ resource utilization, which, David, I was very interested to hear about the work that's being done by ESA. You were talking about titanium and oxygen. We all know that ISSRU is something that is thought of as an essential, perhaps more from Mars than on the moon, even.
Yeah, well, I mean, space resources is a big topic which deserves a session of its own. And the point I like to make is that before people can use space resources to support sustainable exploration, we have to do the science and the enabling technology first. And when you start to do the calculations of how much energy you need to extract resources in a meaningful scale and use them, it can become quite daunting. But also doing that, if you can do that, it creates capabilities which are definitely needed for Mars exploration. So I think that it's an important scientific and research topic. And so we have a plan, and it's a long-term plan. And we have some countries in Europe, for example, Luxembourg, that is particularly interested in this topic. And so we set up jointly a space resources innovation center to really focus on the science and technology. And there's some cool work going on right now, as I've already showed you, but also things that are coming along for the future. And so some of our moon exploration activities include, yes, taking the drill technology we developed for ExoMars and developing an ice drill that we can take to the moon. And that's in cooperation with Roscosmos, with the Russian space agency, the Lunar 27, to try and get a meter or so below the surface of the lunar regolith.
We are near the end of our time for this first panel discussion at the 2021 Humans to Mars Summit. Kathy, I'm going to come back to you with a little bit more of a philosophical question and let you lead off. Any doubt in your mind that the ultimate target remains the red planet, putting boots on Mars?
Let me tell you, we have a red planet on all of our charts, so we're aiming towards that. I mean, I think, you know, even if you look at the orbit that we have Gateway in, it's chosen in particular based on for us to go get ready and be able to have the features that we can have the Gateway in to be able to have us be able to get ready for a transit to Mars. So I've been getting ideas for a new chart for next year that starts showing all the different things in our architecture that are there because we're getting ready for Mars. And you know, I always tell Thomas, I said, Zurbuchen, I say, I'm following you now, but at some stage we'll be helping you when we get there to be able to really be able to do the science. I told him, I said, a human would have been able to scoop up the sample and been able to put it in a container and take it back home. And so it just shows once again that, you know, having people there kind of opens up the ability to do additional science and technology work. And I'm hoping one day to be there helping Thomas on the red planet.
Eyes on the prize still. Hiroshi, Sasaki, please, if you have anything to add about that ultimate target of Mars.
Yeah. So for the Mars missions, we first of all we also targeted in the water ice on the Mars. This is very interested. Our Japanese science community is very interested in water ice on Mars. So it will be used for the not only used for the human missions, and also it can be used to analyze how to water how I'm sorry water Earth's water is come from the where the ice waters come from. So this is a very scientific interest in moon or Mars mission.
And David, we'll give you the chance to give us the brief last word here.
Thank you very much. Well, thank you for the panel discussion. I mean, yes, Mars is our horizon goal with our exploration program, absolutely. But it doesn't stop me dreaming of sending ice climbing explorers into the fissures of Enceladus in the next century. Thanks.
Talk about the ultimate prize. I'm with you on that, David. Thank you, all of you. You have helped us get the 2021 H2M off to a great start. I had so many more questions, but I suspect that many of these will be addressed in the coming sessions over today and the next 2 days of the Humans to Mars Summit. Stay with us because we are only moments away from the next panel, one that I will be moderating live this time. A planet of robots. You've already heard a little bit about some of those robots, robotic explorers, our emissaries on the red planet. We're going to be diving a little deeper into those robots in just a couple of minutes. Please stay with us.